All right, so you ready to dive into something kind of wild? We're talking chaos, but get this. The structure of chaos. We've got some awesome source material to dig into, all about chaos theory, fractal geometry, and how these concepts play out everywhere, from like heartbeats to entire galaxies.
I think what's really cool is that chaos, it's not just randomness. The more we look at it, the more we see it's actually this like super complex form of order, and we're only just starting to understand it.
Okay, yeah, that makes sense. So let's break this down a bit. One of the big things from chaos theory is the butterfly effect, right? But like beyond the whole butterfly flapping its wings and causing a hurricane thing, what are some actual real-world examples where this sensitivity to starting conditions matters?
Well, take weather forecasting, for instance. Meteorologists, they use super complicated models, but even a tiny change in the initial data, like way early on, can end up giving you totally different predictions in the long run. That's why we might have a pretty good idea of tomorrow's weather, but trying to predict a hurricane weeks out, that's still a huge challenge.
So there's kind of like this built-in limit to how much we can predict, even with all the tech and data we have. That makes me wonder, how do scientists even begin to study systems where, like, the tiniest change can have such massive effects?
And that's where fractals come in. They're these infinitely repeating patterns, and it's kind of crazy we find them embedded in chaotic systems. It's like finding a secret code or like seeing a structure where at first it all just looked random.
Yeah, I've seen those fractal images. They're definitely cool to look at, like the Mandelbrot set. But besides the visual aspect, why are they so important for understanding this whole chaos thing?
The key thing with fractals is this self-similarity across different scales. Imagine a coastline, right? From far away, it has a certain shape. Zoom in closer, you start to see inlets, bays, and they sort of mirror the overall shape. Keep zooming in even further down to individual rocks, and you see that same pattern repeating itself. And that's what's crucial. This self-similarity helps us analyze chaotic systems and start to make sense of how they behave.
So it's not just about the pretty pictures. It's like a tool to make sense of complex stuff. You mentioned coastlines, and obviously those are natural. Where else do we find these fractal patterns in the real world?
Oh, they're everywhere. You see them in trees, how they branch out. You see them in our own circulatory system, how it's structured. Even the way galaxies are spread out across the universe, it follows fractal patterns. And seeing fractals everywhere like this, it kind of makes you think there's a deeper principle at work, some fundamental link between chaos and, well, how reality itself is structured.
Whoa, that's a heavy thought. Makes me think about our bodies, Are there places where we see this chaos and fractal stuff happening inside us too?
The human heartbeat is a perfect example. We tend to think of it as this totally regular rhythm. But a healthy heartbeat actually has tiny variations, little irregularities. And it turns out those irregularities are super important for the heart to adapt. And if you plot those fluctuations over time, guess what? You get a fractal pattern.
So even at that basic level, our bodies are using chaos to, like, stay alive. That's kind of mind-blowing. It makes you wonder if maybe we've been too quick to think of chaos as always being bad or destructive.
Exactly. And for a long time, there's been this idea that the quantum world, the world of tiny particles, is ruled by pure randomness. But even there, we're starting to see patterns that look a lot like fractals, which means even at that incredibly small scale, there might be an underlying structure to what we thought was completely random chance.
So even quantum events might have some predictability. That's wild. What does that mean if we can find order in what we thought was totally random?
That's a huge E question, and scientists and philosophers are like really trying to figure that out right now. If we find that even the quantum world has these fractal patterns, it could totally change how we understand the universe, and maybe even how much we can ever actually predict about the future.
That leads us to something that's always fascinated me, emergence. How does that fit into this whole chaos and structure picture?
Emergence is basically the idea that you can have simple rules that end up creating super complex and seemingly unpredictable outcomes. Think about an ant colony. Each ant follows these really basic rules, but together they create these incredibly organized societies with all these different roles and behaviors.
Right, so the whole is greater than the sum of its parts. We see that with, like, schools of fish, flocks of birds, even how galaxies form. Are you saying this emergence thing might be happening on a universal scale?
A lot of scientists are looking into that. What if the universe itself is this giant emergent system? And what if chaos is like the basic building block of it all? It's a pretty mind-blowing concept, but it does make you wonder, how much can we really predict if everything is ultimately connected through these crazy chains of cause and effect?
All right, so we've got these chaotic systems with hidden fractal structures. And maybe this idea that complexity comes from simple rules interacting in chaotic ways. But how does any of this help us actually predict anything, especially if we're dealing with this super sensitivity to starting conditions?
Well, think about it like this. If you try to model a single gas molecule bouncing around, it's chaotic, right? Seems impossible to predict. But zoom out. Look at trillions of those molecules. Now you can start to predict their overall behavior, things like temperature and pressure. Same idea with chaos theory, really. We might not be able to predict every single chaotic event, but we can start to see patterns, make predictions at bigger scales.
Yeah, okay, so kind of like we can't predict every little gust of wind, but we can understand climate patterns overall. But if we can't get down to those tiny details, what's the point of even understanding chaos theory? Like, how does this apply to our lives outside of science and weather forecasts and all that?
Well, one really cool thing is it helps us understand how systems adapt and evolve. Like a system that's too rigid, too predictable, it can easily get messed up by even small changes. But if a system has a little bit of chaos built in, it's got the flexibility to adapt, maybe even thrive in unpredictable environments.
So, like, how does that chaotic system thing play out in something like, oh, I don't know, the business world?
Imagine two companies, right? One is super structured, everything top down, hates any change from the plan. The other one, they're a bit more flexible, encourage people to experiment, adapt to things as they come up. In a stable market, they might both do fine. But when things get volatile, the company that can adapt fast, they're the ones who are going to survive and probably even do better.
So it's not about avoiding chaos completely. It's more like learning to use it to your advantage, to be more innovative and resilient. Kind of reminds me of those computer simulations, the cellular automata, like Conway's Game of Life, right? From what I understand, it's all about simple rules creating these crazy complex outcomes.
Exactly. Cellular automata are a great way to see how those simple local interactions can build up into all these intricate patterns and behaviors. It's a visual representation of emergence, and it shows us how complexity can come from really basic foundations.
It's almost like a tiny version of the universe, these little individual elements interacting and creating something way bigger than themselves. But going back to those real-world applications, how does understanding chaos and emergence actually change the way we approach things like decision-making or problem-solving?
Well, for one thing, it makes us more comfortable with uncertainty. A lot of times we try to plan everything perfectly, like we want total control. But chaos theory reminds us that there are always going to be unexpected things happening, consequences we didn't see coming.
So instead of stressing about predicting every possible outcome, it's more about being able to adapt and respond to whatever happens. It's almost like a shift in how you think, right?
Absolutely. It's about embracing those unexpected things that can sometimes lead to the best opportunities. It's about learning to navigate all those twists and turns in life with more grace, more flexibility.
That really hits home. All those times I've stressed about making the perfect choice, only to find out that the path I thought was wrong actually led to something even better.
Exactly. And it's not just big life decisions either. It applies to everyday problem solving too. Instead of getting stuck trying to find the one right solution, we can be open to different possibilities. Experiment a little. See what unexpected solutions come up in the process.
So less about forcing a specific outcome, more about setting things up for positive emergence, let things unfold and see what happens. But how do you actually do that? Cultivate that adaptability, that comfort with uncertainty. Seems like so much of how our society is structured is all about minimizing risk, making everything predictable.
Definitely takes a conscious effort. Got to be willing to challenge how you think. Those ingrained patterns. Things like mindfulness can be really helpful, learning to be present with whatever comes up without judging it or pushing it away.
So developing a kind of inner resilience, being able to handle those chaotic moments without losing yourself. It's like becoming a surfer, learning to ride the waves instead of getting tossed around by them.
That's a perfect analogy. And just like surfing, it takes practice, patience, and a willingness to fall down and get back up again.
Right. Okay, so we've talked about how chaos theory changes how we make decisions, solve problems. But earlier, you mentioned something that I'm really curious about, the fractal universe. What does that even mean for the cosmos to have a fractal structure?
We've talked about how fractals are everywhere in nature, from snowflakes to coastlines. But when astronomers started mapping out where galaxies are across huge distances, they found something surprising. The distribution of galaxies, it also has a fractal pattern.
Hold on, are you saying the structure of the universe itself, like on the grandest scale imaginable, might follow the same patterns we see in a seashell or a tree branch?
It's a truly amazing idea. Imagine zooming out from our planet, past our solar system, through our galaxy, and seeing this incredible web of galaxy clusters, all arranged in a fractal pattern that extends as far as we can see.
Like the universe is this giant, infinitely complex fractal with every level mirroring the structure of the whole thing. But if space is fractal, could time be fractal too?
That's a great question. Scientists have actually found that the way events happen in time, things like earthquakes, market crashes, even periods of war and peace, they seem to follow patterns that look a lot like fractals too. It suggests that time itself might not be this straight line, this constant flow that we think it is.
So instead of a straight line, time might be more like a spiral, with patterns repeating and echoing across different scales. This is making me rethink my whole concept of history.
Exactly. Maybe history doesn't repeat itself exactly, but there are these recurring themes, echoes of the past, that show up in unexpected ways. And maybe we can understand these patterns. We can get a deeper understanding of the forces that shape our world.
It's wild to think those same patterns in a seashell could be, like, reflected in history. But if chaos is basically built into the universe, does that mean we're all just along for the ride? Like, do we even have any control in a world that's ruled by these crazy, complex systems?
That question has been bugging philosophers and scientists forever. But chaos theory doesn't say we don't have free will. It just gives us a new way to think about how our choices interact with these bigger systems.
So it's not about whether we have free will, but more about how that free will plays out in a system that's unpredictable.
Exactly. Think of it like paddling a kayak down a river, right? You can steer, you can paddle, make choices about where you want to go. But the river has its own currents, obstacles you got to navigate. You're part of a system that's bigger than you, and your choices affect that system, and the system affects your choices.
It's like a balancing act between, like, taking action and accepting what you can't control, right?
Exactly. And this is where that fractal time idea gets really interesting.
Yeah.
If time itself has that self-similarity, those repeating patterns, it means our actions might have consequences that go way beyond just this moment.
So even small choices could have these ripple effects across time, shaping not just our lives, but other people's lives too, in ways we might never even realize.
It's a humbling thought. It shows how connected everything is, Our actions, our thoughts, even our tiny choices, they all become part of this giant tapestry of the universe.
It's a lot to process, but it's also really inspiring, isn't it? Like, it means we all have a part to play in how things unfold, even with all the chaos.
Absolutely. It shows how important it is to make choices that line up with what we believe in, with the kind of world we want to live in, because those choices can spread out and affect the future in positive ways.
So chaos isn't just about randomness and unpredictability. It's also about potential, about the chance to create something new and meaningful, even with all the random interactions of the universe.
Exactly. And it reminds us to be curious about the world,
Yeah.
Look for those hidden patterns, the unexpected connections, the beauty that comes from chaos and order working together.
Wow, this deep dive has been quite the journey. We started with the structure of chaos, went from tiny particles to the whole vast universe. We found fractal patterns in everything, from heartbeats to history, and we saw how these ideas can change the way we understand the world and our place in it.
And most importantly, I think we learned that chaos isn't something to be afraid of. It's something to embrace. It's a reminder that the universe is constantly changing, and within all that change, there's incredible beauty, creativity, and potential.
So to wrap things up, I'm going to leave you with a challenge. Look for the fractals in your own life, Notice those patterns, the repetitions, the self-similarity that's all around you. Be open to those unexpected detours, those chance encounters. And remember, in a universe that's shaped by chaos, even the smallest things you do can have big ripple effects. Keep exploring, keep asking questions, and never lose that sense of wonder.